Okay, I'm going to show a few things here in BlueJ. So if you want to download this at bluej.org, you can get this program and have it on your home computer. But for right now, I'm just going to show a couple of different things that we'll use throughout the year. Okay, so right now I'm creating a class, which is actually a lot more than this, but for right now, you can just think of it as a place where we can put code and run programs. Okay. So I have a class called tester. This is the name of the method that we'll pretty much, at least right now, use for everything. Okay, so we may use other methods, but we'll always kind of start it with this main method. Start our program with this main method. So you don't need to know what it means. You can just copy it from project to project, but it's going to be our main method. So today I want to talk about, and this might take 20 minutes or so. So I want to mention these four different types of variables that we'll use. We have integers, or just ints. We have doubles. That can, an integer is a whole number. Negative, positive, 0, those are all ints. A double can also contain a decimal, so we'll need that if we're dealing with some kind of percentages or whatever. Anytime you need a decimal, that would be a double. Boolean is just going to measure, just going to hold either true or false. And then a string, notice how the string is capitalized here. A string can hold letters and numbers and symbols, kind of in one piece. Okay, so these are primitive. Primitive means they came standard in Java. Int, double, Boolean. There's a couple more. String's different. It's a class just like we're creating here that somebody else has already created, and now it comes. We import it automatically whenever Java loads, but it is a class. Okay, so I don't know why that erased. All right, so first thing I'll do is show some stuff with integers. So int a. So first of all, you can declare an integer like this. This is the type. This is the variable name or the identifier. So, and then you can give it a value like that. So now a is 5. So that's one way to do it. The more common way to do it is just to do it all in one time if you know the value. So sometimes we still might declare a variable and define it later or initialize it later. But what's common is that we know the variable, the value, and we'll set it there. So I have int a equals 5. I'll do int b equals 3. Okay, so I have two ints a and b. And just to show you some things that we can do, I will print. So this is the command. May seem like a lot to just print something, but this is coming to the terminal window. And it's either going to be system.out.print or system.out.println. Println would take you down to the next line after you print. So, and I'll try to show an example of both of those. So if I did a times b, right now a is 5, b is 3, that should give me 15. So the way you run a program is you can compile it. It tells me, yeah, you're good, no syntax errors. Click out to where you have your project with all your different classes. Right now it's just one class. Right click on that class and run my main method. Just leave this the way it is. Okay, say okay. So there it says that's 15, which is what we planned on seeing. Okay. Now another thing is to realize that all of these variables are easily changed. So instead of thinking of a variable in math where it's always the same thing, variable in Java is kind of more like a whiteboard idea where it can hold a value at 1 minute and then hold another value right after that. So I can easily change b to b7, to which now if I print it, I might need to clear this, but if I print it, I should get 35. Okay. And then I have this clear screen at method call, which means every time I run a method, it clears whatever was there previously. Okay. To show a couple of other things, so multiplication, addition, subtraction, they all work exactly like you would think they would. However, if I did, I'm going to go back to my 5 and 3 example. If I do division for integers, integer division is actually very, very useful, but it's a little unintuitive at first when you see it, especially for math people. So I have a divided by b, 5 divided by 3. So we would think that's 1 in 2/3 or 1.6766 repeated. But this is integer division. So what happens is it just gives you how many times 3 goes into 5, which is 1. Now there are some things left over, but it just gives you 1. This is integer division. Okay. Now, if I wanted doubles where it actually computes the division the way I want it, I might want to declare these as doubles, and I'll show that in just a second. But right now, very important to note integer division. If you divide 2 integers, it will tell you how many times it goes into it, but truncate whatever's left there, any remainder. Okay. Now the other thing we'll learn is this symbol. This is the percent sign, but it's read modulus or mod. So a mod b, 5 mod 3 is the remainder. So what's the remainder when 3 is divided into 5? It would be 2. So 3 goes into 5 one time, there's 2 left over. So that's modulus. Okay? 2. Alright, so that's pretty much what I wanted to tell you about integers. Those are the operations: addition, subtraction, multiplication. The division, the way division works in integer for ints, and the modulus. Okay? Now, if I did 5.3 here, and I said, well, what is int a is 5.3? Well, it's supposed to be an integer. 5.3 is not. So if I compile that, I get this error message. And I don't know why it disappears. It used to not disappear, but you can just kind of drag your cursor to get it back. But I can't put a double there, so that's the problem. Okay? So now, what if I did double c equals 4? So you might think right off, well, that's a problem too, because you can't put 4 into a double because 4 is an integer. Yeah, but 4 also can be a double. It can be 4.0. Okay, and if you printed out C, it would give you 4.0. Okay, so it converts it to a double decimal, which is just a 0.0 on it. Okay, so we have that for doubles. The other thing is, we showed you how when integers divide. So what if I printed out C divided by B? So you got to figure out, well, what's going on? We got an integer and a double. Well, if you have a double and an integer combined, it's always going to convert to a double. So 4 divided by 3 is not going to give me 1. It's going to give me 1.3 repeated. And you can kind of see how doubles work here. It doesn't go on forever. Sometimes you might even get like a 5 here or something like that. So doubles aren't perfect, but they give you really, really good accuracy up to like 9 or 10 decimal places. Okay? So that's ints, that's doubles. To show you a little bit of how they can interact with each other, ints and doubles. And we'll spend more time throughout the year on that concept. Now the next thing I want to show is a Boolean. So a Boolean variable, I've just deleted the other stuff. A Boolean variable can hold something like 5 is greater than 3. Because a Boolean can either be true or false. So right now, B would be true. Because 5 is greater than 3. Okay? So Booleans only hold true or false. Okay, so the other thing I would show is, and just like before, you can easily switch B. You don't you only declare a variable's type one time. So I don't put Boolean here. But I've already declared it as a Boolean, but I can change its value. So I could do 5 is greater than 3 and 4 is equal to 3. So I just do two new things. This is and. The two ampersands. And this is equals equals, which would check to see if two numbers are equal. So notice I used an equal sign here for assignment, which means I'm assigning the right side of this equation to the left-hand variable. But equals equals checks to see if they're equal. So it's either going to give you back true or false. So now this says 5 is greater than 3, which is true, and 4 is equal to 3, which is false. And means both of those two things need to be true, right? This has to be true, and this has to be true in order to be true. So when we print it, it's going to be false. Okay? And the other symbol, similar to that, two vertical lines, is OR. So now OR in Java means that this can be true, or this can be true, or both of these two things can be true. So any of those three things is going to cause B to be true. So as long as one of these things is true, or both, B will be true. It's an inclusive OR. So since 5 is greater than 3, one of them is true. We're going to get true. Okay, so that's the difference between and OR. And then the other operation that I will show here for Booleans is the negation. So negation of 5 is greater than 3. So negating something is simply read as not. So not 5 is greater than 3. So 5 is greater than 3 is true, and I'm just going to change that, negate it, to false. So B would be false. Okay? And then the same kind of idea with negation is you could do 5 does not equal to 3. So that is kind of like negating the equals equals, but you don't put a not and then equals equals. It's just not equals. That's the kind of operator that goes there. But that gives you back true if they are not equal. So 5 is not equal to 3. So B is true. And we can check that. Okay. All right. So those are the three primitive types. Now I want to split the two videos up here just so you can remember. Ints, doubles, and booleans. There's some more. Those are the only three throughout the whole course that you have to know. Ints, doubles, booleans. Okay? So I'll stop this, and then second part of the video, which will be much shorter, will be about the basic string operations.